Hello, my name is Gaurav Gambhir, and I'm a technical leader for Cisco ACI Solution and CX Organization at Cisco. Today's topic of discussion is Phantom RP and IPN for ACI Multipod Fabric and some common misconfigurations around it. First, let's try to understand why do we need Phantom RP and IPN to begin with. ACI depends on multicast capability in IPN to send bump traffic, like ARP and unknown unicast between pods. We cannot use PIM ASM due to scalability requirements. Only PIM Biter is supported. Since PIM Biter does not support any functionality for RP redundancy like Auto RP and BSR for PIM ASM, we use Phantom RP. Phantom RP is not a new feature which was introduced to provide RP redundancy for PIM Biter. Once you understand how it actually works, you will realize it is nothing but a routing hack. As the name suggests, IP address configured to be RP for PIM Biter does not exist anywhere. Each router wanting to be primary or backup RP for the PIM Biter is configured with a loopback address that has the IP address in the range of RP address with a different subnet mask. And based on the longest prefix match, only one device acts as an RP. Redundancy is kind of inbuilt, with routing convergence happening for the prefix if the device which is acting as a primary RP goes down. Additionally, you can also achieve RP load balancing if you use the same logic and split the multicast range with two or more groups with different devices configured with longer prefix matches. Here is a configuration example for Phantom RP. Notice all 4 IPN devices in this topology are configured with same IP address of 192.168.255.2, but with different subnet masks. And it is not the RP address. RP address is 192.168.255.1. All devices will choose IPN4 as primary based on the longest prefix match. And in case IPN4 goes down, IPN2 will become the primary simply based on the routing convergence. Let's go over some common issues in IPN and Phantom RP configurations. The most common misconfiguration we have seen in the field is someone configures the RP address on the loopback itself on the IPN device. As pointed out earlier, as the name suggests, RP address is not supposed to be configured anywhere. An IP address configured locally on Cisco router is installed in the routing table as a /32 route. Hence, it will always become longest prefix match. With this configuration mistake, all IPN routers will think they are the RP for the given group. And you will end up with broken multicast tree in your IPN. Second most common issue we have seen is loopback for Phantom RP is not configured as OSPF point-to-point network type. By default, loopback address in OSPF is considered stub network and will advertise as /32. Since the loopback is not supposed to be configured as the RP address and only /32 for non-RP addresses advertised by default, none of the routers in IPN are selected as RP. Just like the previous example, this misconfiguration is also not directly related to the Phantom RP configuration itself, but with the underlying OSPF configuration, which can break multicast in IPN. For the Phantom RP, RPF interfaces should always point to IPN devices and not towards the ACI spines. If each spine is connected to multiple IPN routers and also have low-speed links between those devices, based on the OSPF metric assignment, for RP reachability, IPN routers may prefer link towards ACI fabric. Since ACI spines do not run PIM, those interfaces cannot be valid RPF interfaces and will drop multicast traffic. Just ensure you have same or lower OSPF metric configured on links between your IPN routers. I quickly want to touch upon some unsupported design and configuration issues related to IPN here as well. Assume you have an existing VPC setup on your standalone Nexus devices and now you're trying to use the same hardware as IPN as well. As shown in the example, IPN devices in the same data center are VPC peers. IPN1 and IPN2 see each other as PIM neighbors over the VPC peer link. If multicast traffic from pod 1 lands on IPN1, and based on routing, if it prefers peer link towards IPN2 to forward the traffic towards RP, that traffic will be dropped because PIM neighbors over VPC is an unsupported configuration. The fix in this case would be to introduce new links between IPN1 and 2 and have OSPF and PIM neighborship over the new links and ensure it is the preferred path for RP reachability. Another unsupported configuration I want to highlight here is SVI as L3 interfaces on IPN devices towards ACI spines. In most cases, we have seen this is due to product limitation that the device does not support routed subinterfaces, which is a well-documented requirement for ACI spines to IPN connectivity. For more details on this topic, you can refer to Multipod white paper and Cisco Live presentation for ACI troubleshooting multipod presented by my good friend Joseph Young. Thank you for watching.